Hello, Algebra Tours. Today we're going to be talking about piecewise functions as another kind of special functions in this unit. So we're going to need notes, calculator, and a pencil. With that, our learning target today is given a piecewise function, I can evaluate for a specific x value. So before we even get started, we should probably talk about what a piecewise function is. And a piecewise function is a function made up of pieces of different functions, which results in having different domains or different x values. Okay? So in real life, if you were at a job and you made $850 an hour up to 40 hours, and after 40 hours you made time and a half, at 40 hours, you would switch the way that you calculate to get paid in the new function, right? So let's talk about that real life situation and let's talk about the mathematical notation that's going to happen with these piecewise functions. So let's use the function y is equal to 8.5x for 40 hours or less, right? And then we're going to use the function y is equal to 12.5x for hours that are over 40. But we want to combine this into one function. So how that's going to look is we're going to say y is equal to, with this squiggly bracket, 8.5x for when x is less than or equal to 40. And then we have another piece that says y is equal to 12.75x for when x is greater than 40. So this is how we're breaking up our function into two pieces. The first piece being 8.5 times x and the second piece being 12.75 times x. So that's the mathematical notation for piecewise functions. That's how we're going to be writing piecewise functions throughout the rest of the year, the rest of this video, and so on, okay? So make sure you understand what we're talking about when we have a function like this. We're saying y is equal to that first portion, 8.5x, when x is less than or equal to 40, and then y is going to be equal to this part of the graph when x is greater than 40. So it's all dependent on what our x values are going to be. Then our graph is going to change, okay? So we're going to start with piecewise functions by evaluating them or finding the y value when we've been given an x value just from looking at the function. So in example 1, we're given this piecewise function and it says that y is equal to 2 times the absolute value of x plus 4 minus 2 if or when x is less than 3. And then our function is equal to 1/2 x plus 1 if or when x is greater than or equal to 3. So we need to find the y value when we've been given x is equal to 5. Remember when we say f of 5, we're saying when we plug in x for, or when we plug in 5 for x, what is my y value? So if x is 5, we're trying to figure out which piece are we using to solve for y. So we have if x is less than 3 or if x is greater than or equal to 3. Well, 5, my x value, is greater than or equal to 3, so we're going to plug in 5 into that equation, okay? So we're going to say f of 5 is equal to 1/2 times 5 all plus 1. So 1/2 times 5 is 2.5 plus 1 is 3.5. So f of 5 is equal to 3.5. Let's try another one. What if we plug in f of -4? Or what if we plug in -4? So -4 is less than 3. Remember, -4 is representing my x value, and that's less than 3. So we're going to plug in -4 into this top part of our function, into that piece of the function. So we're saying f of -4 is equal to 2 times the absolute value of -4 plus 4 minus 2. So start with what's in bars first. -4 plus 4 is 0, so we have 2 times the absolute value of 0 minus 2. Well, the absolute value of 0 is 0, so we're saying 2 times 0 minus 2. Well, 2 times 0 is 0 minus 2. That means that our final answer is going to be -2. So what we're saying is the function at the point x is equal to -4 is equal to -2, or my y value is equal to -2 when we plug in x as -4. All right, last one. When x is 3, so when x is the value 3, we're going to use this part of or that piece of the function. So we're going to say f of 3 is equal to 1/2 times 3 plus 1. 1/2 times 3 is 1.5 plus 1 is 2.5. So we're saying f of 3 is equal to 2.5. So basically, when we're evaluating piecewise functions, we need to figure out what our x values are, or what we are trying to plug in. So in this case, in function notation, what's in the parentheses, and then you look at the part of the function, the piecewise function, where it tells you the restriction on x. So for this first one, we said when x is less than 3, and then this other one was when x is greater than or equal to 3. So that made us figure out where we're plugging in our values for x on the different pieces of the function. Okay? Let's look at another example. Okay, same idea, just a different piecewise function. So now we're saying f of x, or y, is equal to 3 pieces. This piece, and this piece. So the first piece is 2x squared plus 1 when, or if, x is less than 4. Then the second piece is saying 4x plus 2/3 if x is between 4 and 7. And notice it's less than or equal to here, and this is just a less than. And then our third piece is that f of x, or y, is equal to 3 whenever x is greater than or equal to 7. Okay, so we first need to find f of -2. So when x is -2, we're plugging it into this piece of the function, or that part of the function, because it says if x is less than 4. Well, -2 is less than 4, so that's where we're going to plug it in. So we say f of 2 is equal to 2 times a -2 squared plus 1. Square it first before we multiply. PEMDAS, people, PEMDAS. Everybody forgets about PEMDAS, including your own math teacher sometimes. So good reminder for ourselves. Do the exponent first, so -2 squared would be 4. That's getting multiplied by 2, and we're adding 1. 2 times 4 is 8, plus 1, we get back 9. So f of -2 is 9. Now we want to find f when it is 8, when x is 8. And so x is greater than or equal to 7. So notice how in this piece, or that part of the function, there is no x variable going on. We're saying y is equal to 3, or equal to 3, sorry. Y is equal to 3 no matter what you plug in for x. So f of 8 is just going to be 3. Now we need to find f of 4. Okay, so when x is equal to 4, we're trying to figure out which of the 3 pieces are we plugging 4 into. Well, when x is greater than or equal to 4, we plug it into that second piece, or that middle piece. So we're going to plug in 4 into this piece, or that x. So we're saying f of 4 is 4 times 4, all plus 2/3. So we get 4 times 4 is 16 plus 2/3. And if we want to write that as a fraction, then we're going to have to rewrite 16 as a fraction over 3. So 16 is the same thing as 48 over 3. And then we're saying that's getting added to 2/3. So 48 over 3 plus 2 over 3, we just add the numerators. 48 plus 2 is 50 divided by 3. If you wanted to do that in a decimal, you could simply do that. That would just be the decimal 16.67. But I like fractions, so we're going to keep that as a fraction. Okay, so keep in mind whenever we're evaluating piecewise functions, the biggest thing to figure out is which piece are we plugging x into, and that can be found by figuring out the restriction on x in the way that it's been given to us with all the different pieces of the function. And the last example for today. So what if we've been given a graph? Well, a graph of a piecewise function, as you can tell, is broken up into so many different pieces. We have a piece here, and we have a piece down here, and a piece over here. So when you see graphs that look like this, you know that they're piecewise functions because they're broken up into so many different pieces. So we're going to try to evaluate our values when we've been given an x value, and we're going to find that y value given the graph. So we have three examples. If we want to find f of -6, remember that this is my x value. So when we go to the graph, we look at the x value, which is this horizontal axis, at -6. We're saying, what is that? What point is that on the graph? What y value of that point is it on the graph? So it's this point on the graph, which is -6, 5. So we're saying that f of -6 is the y value at that point, which in this case would be 5. If we evaluate the function when x is 1, that would be this guy right here when x is 1. Now we turn into a little bit of trouble because we have a piece down here at 1 and a piece up above at 1. But if you notice, this is an open circle and this is a solid circle. So we're saying that the function is actually being evaluated at 1 where the solid circle is. So the ordered pair that we're finding would be of this part of, or that piece of the function, not this one because that's an open circle. So the ordered pair of this point right here is 1, 3. So when we find f of 1, we're saying, what's the y value at that point? So in this case, it would be 3. Okay, and last but not least, what if we evaluate the function at f of -1? So when x is -1, we have to find our graph, and that's this point right here. What's the y value at that point? Well, the y value at that point is -7. So that's how we would graph, or sorry, that's how we would evaluate if we were given a piecewise function from a graph. So we're just finding where the graph is existing for the given x value, and we're evaluating or finding the y value at that ordered pair on the graph. I want to thank you all for taking such good notes, and I shall see you soon.